Good morning, grade 8. How are you guys doing? I hope you guys have been well. I would like to welcome you to our third lesson in this series of video lessons. If you guys recall, in the previous lesson, we looked at atomic structure. In the previous lesson, we looked at atomic structure. We looked at how the atom basically has a nucleus and how in that nucleus you find protons and neutrons. We also looked at how that atom is surrounded, or that nucleus is surrounded by what we call orbitals, shells. And in those shells are found electrons. And now today, we want to look at a concept, because remember in the first lesson, what did we look at? If you still remember, in the first lesson we looked at the periodic table. Now in the second lesson we looked at the atomic structure. Now today we are going to look at the relationship between the periodic table and the atomic structure. The relationship between the periodic table and the atomic structure. We're going to try and show how just by looking at an atom, you should be able to determine which period or which group or where exactly it is located on your periodic table. That is what we're going to be doing today. Okay, so what are our objectives for today, grade 8? So our objectives for today, by the end of this lesson, we should be able to outline the arrangement of electrons in shells. Okay, so by the end of the lesson, we should be able to outline the arrangement of electrons in the shells. To say, in the first shell, how many electrons do we have? In the second shell, third shell, blah, 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 blah. Right. Now, we should also, by the end of this lesson, be able to describe the relationship between the number of electrons in the outermost shell and the group number. Okay? So by the end of this lesson, you will be in a position where you'll be able to say, okay, so if I'm given this number of electrons in the outermost shell, I should be able to determine the group number of that particular atom. By the end of this lesson as well, right, because these are simple concepts. That's something that I also need you guys to grasp. These are simple concepts. Don't even think that they're difficult. They are very simple concepts. Confirm it. Tell your mind that these are simple concepts and you'll be able to understand them. Right. So we should also be able to describe the relationship between the number of shells and the period number. So if we're able to tell the number of shells, right, the number of shells on an element or an atom, then we should also be able to determine which period that atom is found in. Then finally, we will also talk about group 8 elements, noble gases, right? We will also talk about noble gases. I'm sure by now, guys, you have looked at your periodic table several times and you now have an appreciation of your periodic table. I hope by now you are at that stage. So now let us go into the lesson proper. So as always, please pause the video for maybe 1 or 2 minutes. Just get a chance just to look at the objectives. Okay? It's always important for you to look at the objectives and understand what the lesson is going to be about. So pause the video just for a minute or 2. Okay, welcome back. So the first thing we want to look at is the arrangement, because the arrangement of electrons in an atom. So we talked about in the previous lesson how we have an atomic structure, right? And I hope you recall what we have in that atom. Do you recall what we have in the atom? Yes? So in the atom we will find that we have a nucleus, right? We have a nucleus. So let's say we have this first circle will represent the nucleus. And then inside of this nucleus that I'm drawing, we will have what we call the letter P, representing protons, and the letter N, small n, representing neutrons. Yes? Representing neutrons. Then surrounding this nucleus, remember, this is our nucleus. Surrounding this nucleus, what do we have? We have what we call shells or orbitals. So surrounding the nucleus, we have what we call shells. So another name, so you can call them shells or you can call them atomic orbitals. And in these orbitals, shells or orbitals. Shells or orbitals. What do we find in these shells? What do we find in these shells? In these shells we find electrons. Electrons, right? I'll represent the electrons with the letter E, E minus, because the electron is negatively charged. Because the electron is negatively charged. Right. So in this lesson, general structure, right? So if we have 2 electrons, we are definitely going to have 2 protons. Remember, electrons, number of electrons is equivalent to the number of protons. It's always like that. Right? So if we have 2 electrons here, then we have 2 protons inside. We can also have 2 neutrons, depending on the element and depending on the atom. But the first thing we're going to look at today, right, is the arrangement of the shell. So on your notes, if you are paying attention, if we pay attention to our notes, we will see that we say that electronic configuration. When we say electronic configuration, the arrangement, basically the arrangement, the manner in which electrons are arranged in the different shells that are surrounding the nucleus of the atom. That is the electronic configuration, right? The arrangement of electrons. The arrangement of electrons in shells that are surrounding the nucleus of the atom. Okay? So let me take an element. Which element should we take? I will take the element sodium. It's a common element and it's a popular element. I will take the element sodium, and from sodium I will take an atom of sodium, and we will use that one to try and show how the element, the electronic configuration in sodium looks like. So now if we look at our periodic table, we will find that what is the symbol for sodium? Because the element is known as sodium, right? Its symbol is Na. Its symbol is Na, right? If we look again in our periodic table, we'll find that sodium has a mass number of 23 and a mass number of 23. Mass number, right? There's a mass number and there is an atomic number, right? Atomic number for sodium, you will find that it is 11. The mass number is the addition of the protons and the neutrons, while the atomic number tells us the number of protons that are in that atom. I hope you are still aware of this information. If you just go back to your notes on lesson 2, you will find this information. If you go back to your notes on lesson 1, you will also find this information. If you just go onto any periodic table, okay, you go onto any periodic table, you will find that the mass number and the atomic number will be given on that periodic table. So let's always take the chance, grade 8s, to be familiar. Right? Always familiarize yourself with the with your periodic table. Always familiarize yourself with your periodic table so that you can be able to get to know this information. So sodium, mass number 23, atomic number 11. Right? Then we remember that the number of protons is equivalent to the number of electrons in that atom. Okay. So if we have sodium, right, and we're going to draw now the atomic structure of sodium. We know that sodium has, in the nucleus, I'll put the symbol Na. This is the symbol Na for the element sodium. Okay? Then in its first shell, the first shell now can only be occupied by a maximum of 2 electrons. First shell can only be occupied by a maximum of 2 electrons. Right? So the second shell can then be occupied by a maximum of 8 electrons. So that's 2 plus 8, 10, which means there is still 1 more electron left, and we will put it there. This is what the atomic structure or the electron configuration for sodium would be if you were to draw the Bohr structure. Right. So now if you were to say, write the electron configuration, right, you would then say, first shell for sodium has 2 electrons, right, you put a dot. Second shell for the element for the atom sodium has 8 electrons. Then you put again another dot because there is still one more electron left. The third and final shell has 1 electron. Third and final shell has 1 electron. So that is the electron configuration of the element sodium. 281. 281. So the electronic configuration, as we have said, is then simply determined from the atomic number. If you just have the atomic number, if I just say there's an element which is an atomic number, I'm going to give this as a simple example. This is an atomic number of 15. I don't know which element this is. I don't know what the name of the element is, right? Right. I don't know what the name of this element is. I don't know which group it is in, but I just know that the mass, the atomic number of this element is 15. That is all I have been given. Atomic number. And because I have been given this atomic number, it means that I am able to actually determine the electronic configuration, the electron configuration of this atom. Right. So because it is 15, it means that I know that for every atom, the first shell can only be occupied by 2 electrons. Right? So 2. Now, how many are left? If we have 15, there's still a lot that are left. So the second shell can be occupied by a maximum of 8. Now 2 plus 8, 10, which means we still have 5 more, right? Then the third shell would then have 5 electrons. So this would be the electron configuration. The moment I am given the atomic number, I am able to tell the electron configuration. Right. Now, let us now also look at how effectively we are then able to describe the relationship between the group number and the number of electrons in the outermost shell. The group number and the number of electrons in the outermost shell. Okay? I apologize for their trucks that are making noise outside, but pay attention to the notes that are being given. Right. So, if we have an element such as sodium, may you please at this moment look for your periodic table and try to identify in which group do we find the element sodium? In which group do you find the element sodium? Right? You can look for it either in your notes. You can look for it either in your notes. Okay, guys, again, I apologize for the interruption. Someone needed something. Right, so we were looking at the basic idea. If you look at your periodic table, right, if you look at your periodic table, you will find that the element sodium is in group 1. Okay, so if you just look in the periodic table, okay, where is sodium? Sodium is in group 1. Who else is in group 1? You also have potassium in there. Who else do you have in there? You also have lithium in there, right? All these elements which are in group 1, if you look at their electronic configurations, they will all have 1 electron in the outermost shell. All the elements that are in group 1, if you write their electronic configurations, they will always have 1 electron in their outermost shell. If I was to take a textbook, right? This is the textbook that you use, and I was to look at the element potassium. Okay, the element potassium has an atomic number of 19. Okay, the atomic number of potassium is 19. So if I was to write the electronic configuration for that potassium, right? So potassium, atomic number 19. Right, so if I was to draw the electronic configuration to write it, I would say 2 electrons in the first shell, 8 electrons in the second shell, 2 plus 8, 10, which means 9 are still left. So the third shell can only be occupied by a maximum of 8 electrons. So 8 electrons in the third shell, and then finally in the last shell I would have 1 electron. Right, and what does this 1 electron in the outermost shell tell me? It tells me that the group number for potassium is group 1. Right. Earlier when I gave this example of an element, we didn't know what it was. which had atomic number 15, right? Then it has this electronic configuration, 2 electrons in the first shell, right? I hope you can see it, I hope it's visible. It's 15, which gives 2 electrons in the first shell, 8 electrons in the second shell, then 5 electrons in the final shell. And because it has 5 electrons in the last shell, in the outermost shell, it means that if you go to the outermost shell and you have 5 electrons, that element is in group 5. That element is in group 5. So if you go to group 5, you will find an element that has 15, an atomic number of 15, right? An atomic number of 15. So identify which element that is. So from the number of electrons in the outermost shell, we are able to actually determine which group an atom is in. I hope you managed to understand that. I hope you understood that. The number of electrons, if you just look at an electron configuration, and it has 3 electrons in the outermost shell. It has 3 electrons in the outermost shell, it means it's in the group 3. The number of electrons in the outermost shell tells you the group number. So that is the relationship between electrons, number of electrons in the outermost shell, and the group number. What about the period number? How do you determine the period number? Right. So if we had an element, right? If we had an element, let's think of an element. If you guys could draw at this point, may you please draw, pause the video, you'll pause the video for a couple of minutes, and draw the Bohr structure for magnesium. Draw the Bohr structure for the atom of magnesium. Please pause the video now, right, and draw the Bohr structure of the element magnesium. Okay, welcome back. So now that you have drawn the Bohr structure of magnesium, right, you have found that magnesium, okay, let me draw the Bohr structure for you. Okay, so I have now drawn what I hope you guys drew when I asked you guys to pause the video, the Bohr structure of magnesium. The Bohr structure of magnesium. Now let's look at the element magnesium. This is what it looks like on the periodic table. It says the symbol Mg. It has an atomic number of 12 and there's a mass number of 24. Okay, there's a mass number of 24. If I can just confirm. Right. So mass number 12, mass number 24, atomic number 12. Right. This can be placed differently. You can have sometimes the atomic number be on the top, but if you see 24, know that that is the mass number of magnesium. Right. So because magnesium has 12 electrons, if we were to write its electron configuration, remember its electron configuration, right? So the electron configuration for magnesium, I would write it, let me erase here just a bit, because this is important here. Right, so if magnesium is 12, in its first shell it will have 2, 1, 2. In its second shell, right, because this electron configuration, you get it from the Bohr structure. You get it from the Bohr structure, or you can use this one to actually draw your Bohr structure. Either way, okay. So 2, second shell, 1, 2, 3, 4, 5, 6, 7, 8. This is also an electron, yes. So 2, 8. What about the final shell? 2 electrons, 2H2. 2H2, that is 12 electrons, right? And now because it has 2 electrons in its outermost shell, which group is it found in? It's found in group 2. But we now want to talk about the period number. We now want to talk about what? The period number. How many shells is this magnesium having? Can you count the number of shells that your magnesium is having? It is having 1, 2, 3 shells. It is having 3 shells. Let me pause just a bit. It is having 3 shells. It is having 3 shells. First shell, second shell, third shell. And in which period do you find your magnesium? If you look at your periodic table, such as this one, right? Remember, we have the groups, group 1, 2, 3, 4, 5, 6, 7, 8, and then we have the groups are the vertical ones, and the periods are horizontal. These are the periods. And now magnesium, observe, the period number can even sometimes be written for you, right? So the period number here for magnesium, it is in period 3, okay? It is in period 3. And this period 3 is similar to the number of shells that magnesium is having, So this applies for all the atoms. It applies for all the atoms that are there on the periodic table. The moment you are able to draw the Gauss structure and you are able to tell the number of shells, it means you are then able to tell the period in which the group is, right? So now, because from here you can tell that this magnesium has 1, 2, 3 shells, therefore it is in period 3. It has 1, 2 electrons in the outermost shell, therefore it is in group 2, right? So because it has 2 electrons in the outermost shell and it has 3 shells, it means that it is in group 2, period 3. Group 2, period 3, right? That is how you have a relationship between the number of shells and the period number. The number of shells tells you the period number. Right. Finally, let's just have a look at Group 8 elements. Group 8 elements, also known as noble gases. Noble gases, Group 8 elements, these are elements which have a full outer shell. They have a full outer shell, which implies that they do not need to react. They actually do not react when you have covalent bonding or ionic bonding because they have a stable outer shell. Right. Let's think of examples of group 8 elements. Right. So at this moment, you may pause your video. Right. Pause your video and just take a look at group 8 elements and try to see if you can identify or if you have seen or heard of any of those group 8 elements. Okay, so now you guys, I hope you have looked at your group 8 elements, and on the board I have drawn for you 2 simple group 8 elements in the form of the element helium and the atom helium and the atom of neon. Both of these are noble gases, right? They exist as gases in nature. They occur as monoatomic gases. They occur as monoatomic gases. So if we were to write helium, it would just be He, right? This is monoatomic, which means it only exists as one helium atom. If we were to have something called a diatomic, let me just go off a bit, right? We have monoatomic atoms, right? Monoatomic elements or molecules, right? And then we have hydrogen molecules or chlorine molecules, and these are diatomic. These are diatomic gases. So if you think of hydrogen, how you write hydrogen? Hydrogen, whenever we say hydrogen gas, we write it like this, H2. If we say chlorine gas, we write it like this, Cl2. But for helium, it's just He. There is no He2, right? If it's neon, it's just Ne, right? There is no Ne2. Okay, this is monoatomic. And these are diatomic gases. Diatomic. Monoatomic, diatomic. Right, but moving on, still talking about helium and neon. So these noble gases have a full outer shell. They are found in group 8 of the periodic table. They have a full outer shell, and therefore they do not take part in covalent reactions, covalent bonding, okay, because they already have a stable outer shell. In the next lesson, we'll be looking at bonding. You guys will go and you look at bonding, you look at different covalently bonded molecules, and you actually get to realize that none of them are bonding with group 8 elements, because all of the other elements are trying to achieve what we call a full outer shell status, right? A noble gas status. So if an element like chlorine has 7 electrons, it is looking for that 1 extra electron so that it can also have 8 electrons in its outer shell. An element like hydrogen, it has 1 electron in its outer shell. It is looking for 1 more electron so that it can look like helium. Right? So every element in the period is trying to attain the status of the noble gas at the end of that same period. Okay, so if you look at period 2, right, and then you look at the elements that are there, right, you'll find that they are trying to achieve the noble gas status that is similar to the element in that period. Okay, noble gas in that period. So if you look at our objectives, right, hopefully we have managed to satisfy the objectives of this lesson. We are now able to say, okay, if we are given an element such as magnesium, how are the elements arranged? 2 electrons in the first shell, 8 in the second shell, and then another 2 in the final shell, 2H2 electronic configuration. How does the number of electrons in the outermost shell tell us which group an element is in? Well, how do the shells tell us which period that element is in? Right? We have covered all of that, and I am thankful to you guys for paying attention. I hope you are able to continue to read. There's an exercise at the end of this document. Make sure please that you answer the questions and send the answers to my email address. Do not inbox me the answers in the WhatsApp. Please send them to my email address, as I say continuously. Okay, so this is your teacher, Marshall A.C. Candiado. Thank you guys. You have been great.